dear friends. Welcome to the project Expert Opinion on the platform of Creative Society. Today's technical development gives us a chance to unite, not in the terms of merging to be all the same, but unite on real values, merging the potential for the sake of human life protection, thus creating a society in which everyone could live comfortably. More and more people understand that we need a global change of our society's format to the life-supportive one, the creative one. More and more people join the global volunteer project Creative Society. More information you can find on the website creativesociety.com. My name is Karolina Hronova, and I'm happy to co-host with Ivan.
Hi, my name is Ivan, and I would like to introduce a very interesting man. He's an inventor, self-taught independent researcher, jack of many trades. It's hard to me to list all of the topics he's an expert in, but today we're going to ask him to talk a little bit about a great year, a natural 12,000-year cycle, the cause of climate change and why our planet is warming up. Joe, would you please introduce yourself to the public and let's get this show started.
My name's Joe Bluндел, and I'm an inventor. I've been studying a myriad of fields for a very long time, and I really look forward to sharing a lot of important information with all of you. Well, first of all, I really would like to thank the Creative Society for allowing me to share this information with everybody at this crucial time in all of our lives. And I truly appreciate being invited to speak.
What is happening to the planet? The question that we have is the climate changing? Is it not changing? What's causing it? And so on.
Well, you know, from the oldest writings of man with the Epic of Ardrihasas, we definitely know climate changes, and it changes catastrophically. I mean, the Epic of Ardrihasas is actually the proto-story of what we know as the story of Noah. It is the oldest writing of man that is a story of how everything that was before had been wiped away in a cataclysm. And to look at that, you might just think it's one-off, but it isn't just in ancient cuneiform tablets. This is a story that is in the Yuga cycles of the Hindu mythology. It's been spoken of widely by Plato and the Greeks, called the Great Year. And it was exactly that, the cycle of catastrophe. In fact, if you look at the word cataclysm in Greek, it literally means a downturning of the ages. It could almost be translated as the beginning of the end.
Wow, that's an interesting information. Keep going.
Well, when you look at it, just from the standpoint of why did so many writers feel the need to document this? Obviously, it was imprinted on the racial memory of man pretty deep, but we haven't been here that long. And so, yeah, it's been imprinted from a catastrophe potentially at least 12,000 years ago. But when you actually go back into geologic records, ice core samples, volcanic data, you find that not only has this cyclicity occurred very recently, but quite frequently and exactly lining up with that great year cycle, the cycle of the yugas, if you will, the 24 to 26,000 range of our crossing of a very interesting region of space. And that, in my humble opinion, well, actually, not my opinion, just looking at the brass tacks science of what's getting ready to happen. You see, when you look at, well, you've heard it said that we're on a rock hurling through space. That's not accurate. We're actually on a ferromagnet hurling through space. Over half the mass of our entire planet is a ferromagnetic material. So that means we are existing on a sphere that is highly susceptible to magnetic charges. And there's no greater magnet that I know of than the Milky Way galaxy itself. You see, just like we have a northern and southern magnetic field here on the Earth, so too does the Milky Way galaxy have a southern and a northern field. And that is separated by a 3% region of space, the accretion disk. And we go through that region between the southern field and the northern field exactly every 12,000 years. It lines up perfectly with these catastrophe cycles. So why would that be? Of course, when you start to study high energy physics, it becomes unbelievably clear why that is. That 3% region of space, it actually represents 200 years of that 12,000 year uptick and 12,000 year downtick. So we will be going through an energy region of space that is two gigantic counter-rotating magnetic masses. And what that means is very strong currents. And there's actually, anytime you have one fluid flowing against the other, you've seen in a stream an eddy current, like a little swirl. Well, nature is its most powerful in a swirl. Nature, tornadoes, hurricanes, anything you can think of that is that swirling motion is the most powerful thing that you can possibly imagine. And we will be crossing through that 3% region that is riddled with nothing but gigantic swirling vortices of eddied magnetism. Now, the reason that's so important is that when you look at the Earth itself being highly susceptible to magnetic material, when it goes through that, when those swirls couple with our magnetic field, it will create a massive induction heating inside our planet. And that, I believe, clearly is shown in the cataclysmic data, because you got to have something to heat up a supervolcano to send it off. And what we find in the cycles of cataclysm, 12,000 years ago, right off the coast of Italy, Campi Flegrei. My Italian's rusty, but it's a volcanic field just off of Naples. And it was the supervolcano that erupted 12,000 years ago. And when you think about a supervolcanic eruption, you might think, hey, it's just the people that are near that volcano that are at risk of loss of life and total destruction. But that couldn't be further from the truth. When you look at a supervolcanic explosion, it dwarfs the weaponry of man to an amazing degree. And I say that because the calculation often thrown out about super eruptions is quite literally that it is equal to 1,000 Hiroshima atomic bombs being exploded every single second. It staggers the imagination. But what you're thinking about is actually, it's the core of the Earth, it's the molten activity and it meeting where we live. And when that happens, the amount of ejecta, the amount of matter thrown into the air is so great that it sparks volcanic winters. And that's what really gets us, because when the crops get bad, people start starving, but it's not just the starving, it's just the degradation of health. As a matter of fact, to really illustrate how dangerous volcanoes are, I'd have to point at the fall of Rome. And I know a lot of people will be like, the fall of Rome and volcanoes, what are you talking about? In 530 and 540 AD, there was a series of massive volcanic eruptions that caused a 150-year cooling trend all over the world. And what happened during that? People got hungry, people got sick, and the plague of Justinian set in. And 100 million people in Europe dropped dead in a matter of years. The volcano killed them. They didn't know it. They didn't understand why all the crops failed. But we do now. We understand the exact mechanism that put the nail in the coffin of Rome. And it was a volcano, and not even a supervolcano. So when you go back just a mere 12,000 years, that half great cycle ago, you're looking at a supervolcano that not only disrupted growing conditions around the world, but there used to be exactly where I'm living now was the Clovis culture. And the Clovis culture was from Canada all the way down into Central and South America. The Clovis people ruled the Americas entirely. They hunted mammoths and mastodons and thought that their culture would live forever. And then exactly 1/2 great year ago, a supervolcano put an end to their culture completely. And some people would also point out that it might have not just been a supervolcano. You see, when you cross that 3% region of the accretion disk, there's a lot of material still left there from our formation of our galaxy. And it is riddled with asteroids, meteorites, and things swirling around in those magnetic eddies, just waiting to slam into a body. And so when you start looking at that, why not look to see if there was an impact? And sure enough, exactly 12,000 years ago in Canada, a massive meteor impact also could have very well helped contribute to the unbelievable winter events, but also to the complete destruction of the Clovis culture. And when you think about the destruction of, they were human ancestors, they were humans. But if you just go back a little further, that same volcano that gave them so much trouble is the exact same volcano that exactly 8 great cycles ago wiped the Neanderthals off Earth. That volcano has done a lot in its short time of existence, but hey, it kind of made conditions that gave rise for us. But now that we're here, maybe we can do a little bit better preparation and planning than the Neanderthals did, because things didn't work out too good for them. I would believe that we've begun experiencing the heating, even if we have not yet begun crossing the actual danger zone of the energy. And I say that in the fact that as you approach it, you're still getting, actually, it's kind of nice to hear magnetic domains sometimes, because a lot of people don't really understand the essence of what makes a material magnetic. There are, basically magnetic domains in these ferromagnetic materials that align just like a needle on a compass. Well, we've been traveling, and as we get closer to that field, the field strength increases, and all of that over half the mass in the Earth, all those little bits of metal are pinned real tight together. And so they start to move. And as they start to move, as they get closer to that magnetic field that is much stronger than them, as they begin to move, pinned in that crystal matrix, they create friction and release energy. And that is the primary driver of the heating of not only the planet's climate system, but the core of the planet as well. That's what I believe we really have to, watch out for. That being said, we're not the only ones with a gigantic magnetic field. Our sun has an amazing magnetic field, but our sun also has a very interesting position in this crossing. When you look at what a magnetic eddy does, now it's almost worth bringing up a picture of it, but if you look at the most powerful machines on Earth, every motor runs on electromagnetism, but what most people don't understand is that the largest machines on Earth run on a simple wave oscillation between a north and south magnetic field. That's right. In machines called undulators, a slight bending of the magnetic field is able to take an electron and excite it to extremely high X-ray and gamma ray emissions. And when this occurs, you're able to do a myriad of things. I mean, this is exactly how experiments are conducted at the Large Hadron Collider in CERN. And quite literally, this technology is 40 years old. Mankind has just now understood exactly the force at play when you get the north and south magnetic field mixing. And the earlier versions of undulators were actually just simply called wigglers because they just wiggled the magnetic motion just a little bit. But when you start to look at the actual physics involved in crossing the accretion disk of the Milky Way, you're actually looking at not a magnetic field that's mixing a little. You're actually looking at a magnetic field that is mixing, well, as two gigantic counter-rotating masses would be.
You know, that there was actually in 1997 or 1998, there was a shift of the nucleus recorded. Do you think that there's some connection with this? What you are describing?
A shift of the nucleus of the
Earth. Yes.
As far as, are you talking about like a magnetic a shifting of the magnetic north?
Earth's core shifted northwards towards the North Pole, and that magnetic field started moving faster, even faster from that point on.
Well, that's actually really amazing. I had not heard about a core shift, but I've actually several years ago I did a video mapping the low sunspot times in direct correlation to magnetic movements as monitored by sea mariners. As soon as, of course, the British East India Company started taking very accurate magnetic measurements, you can cross-reference those magnetic measurements with the sunspot cycles and activity on the sun. And where some people might think that when the sunspots are very high, you would be at the most risk of magnetic movement or crustal movement of the magnetic north, but the actual data lined up completely opposite than what I initially thought I would find. And the only theory I have to explain it is when the sun is actually at a very hot place in its cycle and is bursting forth with lots of high energy particles, it's actually, the viscosity is very high. And the best way to illustrate this for everyone to understand is, you've seen when someone takes a pot of boiling water out in the negative 30-degree temperature and throws it up in the air, and then the water just instantly vaporizes and turns to steam. Well, if you did that same experiment with cold water and threw it out in the air, it would just throw out in a big chunk of water. Well, our star is the exact same type of system if you look at its ability to project physical mass. Whenever it's hot and bubbling, supercharged, when those X-rays, or well, X flares, when those X flares occur at a very high temperature region of the star's conduction, it ends up, blasting out a lot of energy, but it essentially dissipates into space, becomes a cloud that could very well heat up our atmosphere over the course of decades. I mean, let's face it, we exist in the atmosphere of the sun. We exist in that energy field. And so when it's doing large ejecta like that, sure, it will have a knock-on effect down the line on the Earth itself. But interestingly enough, in the data that I had correlated with the magnetic cycles, the times when we had massive magnetic shifts were actually the times of least sunspot activity. And the reason for that would be that the viscosity of the sun would be much thicker, lower, slower, so that it would not allow little pressure bubbles. Have you ever cooked spaghetti sauce and have it simmering on the stove? If it's simmering nice and you've got it going and nice and warmed up, yeah, it'll splatter a little bit. But if you just set it on there cold as anything and crank the heat on, you're not going to see a bubble for a little while. Just like the sun, you might not see a sunspot for, oh, hey, it's been several months without a sunspot. That doesn't mean the heat isn't still on. And so the viscosity being lower on the sun and slower actually allows the sun, when it does do a massive ejection, it allows a much more concentrated burst of iron. And it's at those times, well, shoot, just in 2017, when we had those series of X flares, you got to think that quite literally the sun shot our planet with trillions, quite literally trillions of tons of ionized iron that had to have, well, did have an effect. Massive earthquakes. There was a few, one big 8-point something in South America that occurred just a few days after that last series of X flares. And though a big energy event like that, earthquakes, definitely dangerous and destructive, boy, when you're talking about the potentiality of a cool, more viscous plasma ejecting in a gigantic burst that's been able to build up essentially like a pressure cooker. And really, if you think about it, this is the same reason that makes supervolcanoes so dangerous. It isn't a volcano that goes off all the time that is scary. That is something to admire in your backyard. The dangerous things are when you are not seeing the explosion for hundreds of thousands or perhaps 500,000 or more years. That's the scary time, because that pressure cooker has just been building and building and building. And that's, you know, at least in my research, I believe the sun works the exact same way in relation to crustal displacement of that magnetic north. And it actually does correlate exactly with, quite literally, the times we've had magnetic north shift by their greatest degrees have been times of virtually no sunspots, not high sunspot activity.
Very, very interesting. It does correlate with most of the information that we get.
Well, you know, really, this should help illustrate it a little bit. This is just a animation showing two giant counter-rotating masses. What it looks like when you would have something like a northern magnetic field and a southern magnetic field rolling against each other. And it's just simple eddy currents. And when you look at the turbulence induced in just two fields grading across each other, it obviously, it's the swirling and the mixing of magnetic fields that are, well, just like I alluded to earlier with the CERN Large Hadron Collider. You're looking at a machine that functions, that literally gets its high energy X-rays and gamma rays by a slight shift in the magnetic angle. When we're going to be going through that giant dual counter-rotating mass of the magnetic field of the Milky Way itself, we're going to be going through 200 years of that pure turbulence. And that turbulence, yeah, it's going to have the magnetic heating effect on the Earth, but it's also going to excite all the electricity in our system into a higher energy state. And one of the rules in physics is if something can be an emitter, it can also be a receiver. Well, our sun emits plenty of X-rays and gamma rays. And so it's going to be an environment as well that is greatly bombarded with high energy X-rays, high energy gamma. and it will then release those back in proportion to how it was received. So we're really, we face so many issues coming up. I mean, really, we could be facing supervolcanoes, we could be facing asteroid, meteorite impacts, or we could be facing astronomically large solar flares. And, it's something that when you look at something like that, it seems like quite a daunting task to prepare for anything like that. But in reality, even a very harsh volcanic winter, even a massive meteor impact that causes a meteoric winter, like the one that snuffed out the dinosaurs. Well, quite literally, the sun started breaking through almost a year and a half after the major impact. And obviously, many things survived, but the people, the creatures, the times before, nobody's had the ability to prepare like we have. It's really an amazing thing to be coming to this realization where we are. Because if you look, I mean, back with that story of Untapishnu, the flood story, a lot of people don't know this, but obviously he prepared. And not only is there an entire cuneiform tablet about how Untapishnu prepared, but interestingly enough, the curator of the British Museum, a man named Irving Finkel, it was about 5 years ago, was sitting around reading ancient cuneiform texts when he found the plans for the Ark. And I know how that sounds. It's like, what? It's a great book. And there's even a nice speech, a speaking event at the Oriental Institute that he gives, where he talks about going through this process of not only finding the cuneiform tablet that had how to build the Ark, he actually got funding and went and commissioned the Ark to be built. And whereas we all think that, the Ark, a big wooden barge, kind of from our biblical thinking. But as a matter of fact, the type of ship that he used, was called a coracle, a very common ship built all over the world. It just was a very large coracle, a gigantic hemispherical bobber, essentially, able to take wind and waves as if a breeze. And really, when you're looking at the physics of destruction, you want to be in a spherical structure. You want to be somewhere that the wind and water can effortlessly move around. The idea that you're going to stand up or block the force of wind with a square building or a square structure is laughable. Wind and water will destroy them every time. I've seen it in tornado after tornado around where I live. But the structures that aren't destroyed, domes. In fact, there are excellent pictures. I don't have it pulled up right now, but there are pictures from after, I almost want to say Hurricane Ike, 2005. Maybe it wasn't that one, but maybe it was Katrina. There are pictures of, there's this beach and it's matchsticks. There are nothing but total destruction. The surf rose, the waves came in, the wind blew, and all the square stick-built structures were completely wiped off the map. And there's this one geodesic dome sitting there like a little golden pebble, untouched, like it doesn't look like anything happened. Why is that? Well, just as the forces of nature do their greatest destructive capabilities in a sphere, the greatest way we can prepare for those said destructive capabilities is a sphere. And when you start to look at the geometry of the sphere in the relation to building, it not only lends itself to a lot of, well, just pure strength, but the ease and cost of assembly. Why, if you took the exact same amount of material that was in your square structure right now and built a spherical structure, you would end up with 40% more space with the same amount of material used. It's just the surface geometry of dealing with the spheres rather than squares. And you end up with something that is quite literally superior in every way, shape, and form, as far as strength and, if you do it correctly, longevity.
Scientists noticed that the ice caps are melting from the bottom up. So basically the heat, it's not coming from the atmosphere, it's the Earth itself is warming up and the heat is coming from the bottom up. Would you speak a little bit more of that?
Essentially, the reason that the charged particles begin to interact with us is because of the magnetic problems that we'll be facing. You see, we're actually continually bombarded by those particles. It's just that our sun and its magnetic sphere as well is able to protect us from cosmic rays most of the time. That magnetic field and the magnetic field of our Earth actually make our environment completely livable. And the problem I can see is that when you perturb those magnetic fields, it's almost like bringing down the shields on the starship. It allows the energies that are always there to get in even more. And as far as energies, the high energy gamma and X-rays just emitting from the sun are going to be more than enough to heat up our climate system. I believe you do have increased cloud nucleation whenever you have cosmic rays, but I also believe the whole concept of why that occurs is kind of hand in glove with the shields going down, so to speak. It's not just our magnetic shielding going down, but the sun will be going through this supercharged region of space as well, and that it will no longer be able to protect us as it once did, just for that 200-year period.
Okay, and what's causing our magnetic field to get weak?
Well, there's a concept in physics called magnetic coupling, and essentially the weaker field will always give way to the stronger field. And that's why the Earth is so heavily influenced by the sun itself. Well, now we've got another part of the equation to calculate. Not only are we looking at the magnetic field of our planet, not only are we looking at the magnetic field of the sun, but we're looking at the magnetic field of the Milky Way. When you think of the ability for magnetism, magnetic induction is how we currently melt steel now. You can flip a switch and have a piece of steel red hot in seconds and molten in just a few more. Well, that same type of induction, as we go through a magnetic eddy, over half the mass of our planet is going to be subject to that exact same type of inductive force. So just from that standpoint alone, the availability of supervolcanoes erupting at that time, obviously it's no coincidence, 12,000 years ago, it was Campi Flegrei in Italy. 24,000 years ago, 25,000 was the Tambora in New Zealand. That was another massive volcano that lines up exactly with the cycle. Go back 36,000 years, once again, same supervolcano off Italy, the Campi Flegrei volcanic fields. Then you go back, you don't see anything for the 48,000 range, the 48 to 52,000 year range. You don't see any major eruptions, at least no major land eruptions. That doesn't discount that there couldn't have been some submarine underwater type volcanic event that has been lost to a sea change over time. But I'll tell you what wasn't lost to a sea change, the Canyon Diablo meteor crater. You can go just outside of Winslow, Arizona, and see the most well-preserved meteor impact site on Earth. And to stand at it and look across is breathtaking and a little frightening, because you think that this was a grain of sand. Actually, not even a grain of sand. This was a speck of dust in the cosmic sense. And it had the power to alter the course of an entire world. And wouldn't you know, that meteor hit exactly 2 great cycles ago. So it lines up perfectly with, well, with what we're talking about. And I would be remiss if I didn't mention the king of all recent cyclical disasters. And it occurred exactly 1 great cycle after that 50,000-year impact. And that is the Mount Toba eruption of 75,000 years ago. And to give you an idea of how enormous Toba was and how utterly destructive it was, when it went off, genetic research has been proving, and the theory is that the human populace bottlenecked down to 7,000 to 10,000 people. That's right, in very recent geologic time, exactly 3 great cycles ago, human life on Earth was almost completely extinguished by a supervolcano. We're going to be going through those exact same heating events that our planet went through exactly 3 cycles ago that set off that pressure cooker. And if you look at it, there are a lot of supervolcanoes around the world. In fact, there are 7 supervolcanoes that are constantly monitored and constantly show some level of activity. Though recently there's been a lot more activity, which is cause for pause and maybe actually just a wake-up call. I mean, really, when you think about it, that's it's the greatest threat humankind has ever faced. Like any disaster, anything you can think of, the worst war or famine that you can name pales in comparison to if the pressure cooker, one of the multitude of pressure cookers, happens to go off on the Earth during this period.
You talking about Yellowstone right now? Or?
Well, Yellowstone is, yes, the #1 on the list of volcanic supervolcanoes, but there are actually 7 supervolcanoes as categorized by the geological institutes. And I couldn't name them all offhand, but the Campi Fields off of Italy are one. Tambora is still considered a supervolcano, because what you have to understand, you got to understand the geophysics of what makes a supervolcano, rather than a cinder cone or something like that. So essentially, the reason a supervolcano is so unbelievably dangerous is you've got a gigantic magma chamber. And that's where your danger is. See, when you have a cinder cone or a volcano like that, you have a very shallow magma chamber being fed by an external flow of magma. Whereas as a supervolcano, you have a gigantic bulge of magma directly under the volcano. And the danger lies not really in the initial eruption, but the collapse and secondary eruption, because it might just get itself out and start squirting out a little bit. In fact, this is exactly how things like Krakatoa went off. It went off for several weeks, months, in fact. People were starting to come and look at it as an attraction. But as it expended some of its volcanic magma, it then collapsed its caldera in on itself. And what that allowed was all the seawater then came rushing in to that giant pot of magma that was waiting there. And that was the explosion of Krakatoa. That was what traveled around the Earth 7 times. That was the sound that people heard in Sydney, Australia from what, 3,000, 4,000, 5,000 miles away it was heard? Like the volcano actually going off wasn't that dangerous. It was when it collapsed back into its own well of magma. That's when you get all that energy then is released in mass. And obviously, if you're near water, the supervolcanoes near water are obviously more dangerous, because if the calderas collapse in and then the ocean comes running in, then you've really set off the bomb. Then you've got a hydrostatic shock wave that not only ejects massive amounts of material into the air, but you also then create gigantic tsunamis. As a matter of fact, eyewitness reports of Krakatoa, they said the tsunamis were 150 feet high. Same thing when they look at the Campi fields that went off in Italy. They estimate that when that went off 12,000 years ago and 35,000 years ago, that when exactly what I talked about happened, when the caldera ran out of juice to keep pushing magma up and collapsed back in on itself, then the ocean waters ran in. And then the explosion occurred at the level of the sea and put a 100-foot tsunami for everyone's doorstep along the Mediterranean. Like that field right now, if it went off tomorrow, which it very well could, it's still a super volcano. If it went off tomorrow, you would not want to be hanging out on the beach. It would be catastrophic just as much as a Yellowstone explosion. When you're looking at a super volcano, what you're looking at is not the stuff above. You're looking at the size of the chamber below, and really whether or not its caldera collapses back in after an eruption is just luck of the draw. It literally is whether or not the what type of rock was there. You know, Yellowstone is only going to be a super volcano for another 500,000 years, maybe 1 million. And what I mean by that is actually, if you look at the path of Yellowstone, that magma, the magma chamber is actually sitting under the crust that's moving. The magma chamber that is now feeding that Yellowstone caldera used to be sitting in Wyoming. And before that, it was sitting in Montana. And 1 million years from now, as the crust moves over that plume welling up in the earth, that magma chamber will be in Oregon. And 1 million years after that, it will be setting off the coast of Oregon, making new island chains. That's just how the supervolcanoes work, how that welling up of magnetic energy or of magma occurs. And so when we look at supervolcanoes and we look at, it's no mere coincidence that they're occurring exactly 12,000, 12,500, 25, 36, 35, 70, 75. They fall directly on crossing the galactic equator. Now, it can't be coincidence. It is, we know what the physics involved are now. We use said physics to power the highest energy experiments we have on Earth. Would
you unveil a scenario of changes we should be expecting in our lifetime? So let's say we're already seeing volcanoes eruption. We already see ground temperature rise, ice cap meltings, this and that. Wind, I don't know, nuclear winter. Can you describe the scenario? What's going to happen? Why do we need to worry about it?
Well, I would believe that we are well into approaching that plane, or perhaps even crossing into that plane. And the reason I say that is I was actually witness to the largest tornado ever on Earth. I actually, just in 2011, I was sleeping on my porch and I woke up to the sound of what sounded like cannons. Just boom, 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 boom. It was, I thought someone was setting off a firework display that went wrong. And I just couldn't figure out. It was so unearthly. I'd never heard anything like it before. And I then started realizing what was happening and went to the north of my land where I live, right on the edge of, like, less than 2 blocks away from me, houses were destroyed. Like, I was on the very front row seat of the largest tornado that has ever been recorded in history. And it was so violent and destructive, beyond the likes of which anything that had ever been seen before. And it wasn't just that gigantic tornado. Many people forget that the month before the giant Joplin tornado, there was a new record set for 300 tornadoes in a single month recorded. It just blew the doors off any record before it. Well, there's obviously something that's changed. I mean, if that was something that was just a normal function of the atmosphere, we would see a slow logarithmic rise and fall of tornado numbers. We wouldn't just start seeing jumps in the number and intensity of these tornadoes. And so you almost have to attribute it to some external factor. And there's no better factor for heating of the earth. The danger, of course, lies with the magnetism of our material, but the heating of our atmosphere, that's magnetically coupled with the sun. So as the sun starts receiving more energy, more cosmic rays approaching that area of the galactic equator, it will begin to emit more high energy rays itself. That will affect our planet. As far as I think what you'll see and what you've already seen, as a matter of fact, I watch the Weather Channel all the time. No, I don't watch the Weather Channel. That's not accurate. I watch radars. I watch radars all the time. It's actually one of my favorite things. And I have noticed in my couple of decades I've been watching the radar. You can go on there sometimes and see now the most insane oscillations of the jet stream. And, well, exactly what happened in Vancouver a couple of days ago. You would have a massive weather event, the likes of which they're not used to, that floods the entire city and cuts them off from the rest of Canada. And you're looking and you look at what happened, and it is quite literally, whereas we normally see this nice smooth oscillation, which of course is bound to the electrical systems of our sun, that smooth oscillation has been perturbed very recently to a much more chaotic up and down oscillation of that jet stream, which that's exactly how you get massive weather events. It's the mixing of the upper pressure and low pressure. That's exactly how you make famines in one area and floods in another. And we're seeing it now. It's some people might say, oh, it's just because there's more reporting. No, there's been plenty of reporting on tornadoes in America for the past couple hundred years. They've been doing a good job keeping track of a lot of information for a very long time. We are seeing a physical spike. We're seeing an increased number of storms, an increase in the intensity of storms. And there's no other way of saying it, but it has to be the universe doing it. If it was mankind doing it, then it would have been proportional to how much we were adding. You would see a logarithmic rise in everything. You wouldn't see the massive jumps that we've seen. And the only way you can account for a massive jump in energy is if you actually enter a much higher energy region of space.
Yeah, that's really alarming. Right. We are just really coming into tough times. What is your opinion? Why this is not being presented to people?
I believe mankind, and especially the scientific community right now, is suffering from a massive amount of groupthink. And that can be looked at. In fact, there's a paper called The Crisis in Science, and it's an excellent read And what it shows is that a very large portion of scientific research that's been conducted in the last 20 years has not been replicatable. A very high amount of the research has not been replicatable. And what you're kind of seeing is that attention flows where the money goes. And you've got scientists all over the world right now that are being handed a paycheck and saying, you know, to a man with a hammer, every problem looks like a nail. And right now, the scientists of the world have been handed the hammer of CO2, and they're literally trying to shoehorn that into everything you can. Anything you look at now, oh, well, this ancient thing happened because of CO2. This thing happened. This is going to happen. It's groupthink. And I can say, as far as alleviating worries about a runaway temperature on the Earth, there's a little known fact. I don't have this ice core graph showed right now, but I can explain it to a T. Actually, I know the shape of it. So if you look exactly 55 million years ago, I know it seems like a long time. We're talking about the Eocene period. That period of the Earth, the Eocene, was quite literally when we had life from the bottom to the top. We had plants and animals living everywhere, from pole to pole. Everything, the water in Antarctica was about 78 degrees Fahrenheit, and the water at the Arctic was about 78 degrees Fahrenheit. And that was when we had 4,000 parts per million of CO2. 4,000. That's 10 times more than we have now. And when CO2 was 10 times more than we have now, was the most lush environment for life to flourish on Earth. Plants breathe CO2. We're all carbon-based life forms. The idea that CO2 would cause just a total destruction is laughable. But when you follow back from the Eocene with that 4,000 parts per million of CO2, you see the gradual dropping of CO2 and the gradual dropping of temperatures as well. You're not actually seeing dropping of temperatures, so to speak. You are, but it's not related to the CO2. Yeah, there's less CO2 because there's less things alive as it's getting colder. And the reason for the massive temperature drop was actually the Asiatic landmass being run into by India and making the Himalayas. And it logarithmically gets cooler until about 35 million years ago exactly, when the Himalayas, is actually how the Hindus say it, the Himalayas poked into the upper stratosphere and gave us access to super cold weather that came rolling down and changed our environment forever. In fact, when you look at that 35 million year point of when the Himalayas reached that layer in the atmosphere, that is the absolute warmest we will ever get again. It got way, way colder. It dropped off the charts from there. The warmth, the life on Earth, well, we were subject to a lot more varied conditions than we were before. We were literally plunged into, it was a whole new world. We literally experienced winters for the first time. I mean, yeah, if you look in the earliest points of the Earth and the formation before anything was here, it was a huge chunk of ice. And there have been several times before it even started warming where, and I'm talking hundreds of millions of years ago, where the Earth almost completely died because of how cold it got. The greatest threat to man has never been the heat. It's always been the cold. And, you know, people worry about runaway warming. Sure, no matter what the cause of the warming, a lot more energy into the system, a lot more water melting, levels of water rising are going to really hurt coastal communities. It's really going to hurt people that are on a low-lying area. But as things warm up, what that also means is that vast swaths of land become inhabitable. Like when you look at, like I said, when life on Earth was at its peak was when we have warmer conditions, not colder. And so the idea for me, from an agricultural standpoint, I very much want it to be warmer. I fear the volcanic winters. I fear crop failure. And well, I've been building greenhouses for 20 years. And one of the little secrets that people in the greenhouse community do to make plants grow like crazy is we pump about 2,000 parts per million of CO2 into the greenhouse. That's if I could get more in there, I would. It's about the max I can saturate it at, but plants thrive in those conditions. That's exactly how you get plants to grow. And so the idea that CO2 is the danger of dangers is just, it's laughably ridiculous when you think about it from the time scales of when it was the highest, and when you think about what we use it for today to grow food. I guarantee you, most of the greenhouse produce that is on your store shelves right now, pumped full of CO2. They're not trying to skimp on the CO2. They are trying to get as much as they can into that greenhouse and into those plants. And some people might think, oh, but you couldn't breathe in there. You cannot notice 2,000 parts per million of CO2 compared to 400 parts per million. It is indistinguishable for the human body. Absolutely. And so, if anything, I really hope we have a lot more CO2 in the future. I mean, it can be done in a good way, and it can be done in a bad way. And I say that from the standpoint of, we can do a lot more agricultural programs to try to reforest and really revitalize the earth on some levels. Just burning things all the time, maybe not so much. Though, really, I'm more worried about pollution from sources of burning than and I mean real pollution, not CO2. I'm talking mercury, lead, cadmium, the things that will damage a child. Those are what I consider pollutants. My kid could walk around the greenhouse all day long and would never be hurt one iota by breathing 2,000 parts per million of carbon dioxide. It wouldn't happen.
What I want to ask is, we really are going to face very big challenge. We are already facing. How important is it for us as people of the globe to unite in these times?
This is the thing. The fight that we're in now, and this is a fight. The fight that we're in now is for the potential survival of our species. And I'm not saying that to be melodramatic. If we fail, we're not going to have to worry about future generations looking back on us unfavorably. We face the real possibility that if we don't get our act together and start preparing for this cataclysm that we 100% know through geologic records and through the physics, we know it's coming. If we don't begin to prepare for it, we face the very real possibility of extinguishing human life on the earth. A supervolcano is quite capable of completely taking a species out. It took out the Clovis culture 12,000 years ago, and the same volcano took out the Neanderthals 200,000 years ago. I mean, we were almost not the dominant hominids on the earth. We could have been the back seat or even wiped out by them. But the Neanderthals did not prepare for their cataclysm. And when it came, they're gone. Along with, 12,000 years ago, mammoths, mastodons, and the Clovis culture, gone. Never coming back. They're all gone. And so we're looking at preparing to survive. And I say, if we come together correctly if we really put our hearts and our minds to the task of preparing correctly, then we could not only survive what's coming, we could be the first species on this nice little blue marble to thrive through the next cyclical destruction. Mankind right now is essentially an engine that isn't firing on all cylinders. Because when people don't have food, water, and shelter, they don't have time for being creative. They don't have time to think about inventing. They don't have time to even prepare if they're just barely making ends meet. That's no level of preparation. And if we but get the least among us to that basic level, just food, water, and shelter, then it gives mankind a chance to utilize our full potential. Because in reality, everyone is a genius in waiting. Everyone's a Tesla, just waiting to have the time and the space to be able to create. That's, if you want to look at it from a psychological term, they call it Maslow's hierarchy of needs. If you do not have your food, water, and shelter, your brain does not use the prefrontal cortex to plan for the future, to imagine what could be. It literally is shut off because you are in survival mode. And when humankind is in survival mode, all we do is survive. From month to month, from paycheck to paycheck, from maybe catastrophe to catastrophe, just barely scraping out a living, eking by. I think we're ready for more. I think that we've reached a point in our maturity where we could start coming together. And I'm not saying, oh, the government's going to come together. No, we as people can start coming together and really making a massive headway towards the goal of food, water, and shelter for every man, woman, and child. And I believe that it is done through, how do you build a better future? You build a better future. It's not hard concept to understand. In order for you to have a civilization to hand down to your children, in order for you to have something to give them, you have to first build it. And we're still not at that phase yet. Everybody is kind of stuck in the individual. We're going to have to come together. And interestingly enough, even saying that out loud makes me think of, Plato, when he was writing about the great years, it wasn't actually his knowledge. It was a lawmaker named Solon that spoke to Plato that he had went to Egypt. The word Egypt, of course, in the ancient word is chem, where we get the modern word chemistry. So Solon had went to Egypt and heard the stories of the cataclysmic cycles and relayed them back to Plato. And the way that Solon described the cataclysm was this. He said, there's the ascending 12,000 years, and there's the descending 12,000 years. And in the descending, it's the breaking apart of our unity. And it is more and more division. And it's ruled by the god of hate. Literally, the hate is the hate for another person, the fear that someone else is going to take what's mine. That is what rules the descending cycle. And then, of course, on the ascending cycle, he said, that is the force of the love. It's the unity. It's the unifying of mankind. It is quite literally, those are the terms he used. The descending was the division of man, and the ascending is the unification of man. So who's going to unify man? Maybe that's us right now. Maybe that's our job. Because if we wait around forever for someone else to do it, for someone else to build a better future for me and my children, man, I'm going to be waiting a long time. Because everybody's still, at least the governments of the world, me, mine. This is yours. No, you know what? If you think about it, just for a second, we're so much more powerful than the governments of the world. I mean, they're living really off the scraps from our table. Like, even as bad as taxes are, if you think about it just for a second, they're subsisting off of our scraps. We still have the bulk of production power. We still have the bulk of ingenuity. Oh my goodness. We still have the vast resource of creativity that we can tap into when we get everybody unified towards a goal. And I can think of no better goal than preparing for a disaster really does you twofold good. As a matter of fact, if you think about being prepared, there's only one way you can be prepared. You have to live prepared all the time. You have to be in a state of total preparedness. It doesn't mean like you're scared or worried about things. In fact, far from it. You're at a much greater level of calmness when you know that you've got everything taken care of. And along that idea of preparedness, when you really stop and think about it, you're not safe in a world unless your neighbor is also prepared. And so that's really a good incentive to start unifying, not just with everybody on the planet, but with the neighbors around you. Start a community greenhouse. Start building greenhouses in each other's backyards. I'm looking forward to building one for my neighbor to the left, my neighbor to the right. And then after that, the house over and the house over. I'm just going to keep doing that. That's the only way I'm going to be safe. That's the only way I'm going to be able to protect my family. Let's face it, if the shooting starts, me in this wheelchair ain't doing good. So maybe I'm looking at it from enlightened self-interest, but I'm looking forward to seeing everybody have that level of calmness that comes with preparedness. So one of the things about being prepared is also educating yourself of how to sustain yourself. And I realize that might be really difficult inside a city, but there are plenty, actually, I said that, but there are plenty of resources where you can look up the growing of microgreens, the setting up of indoor hydroponics, indoor lighting systems, where you could actually have very high yields in a very small space.
This is a very, very interesting topic. And definitely there are many ways what to do, or many things what we can do to get prepared, to get united. But the first thing actually is to get united. And that is also the point of Creative Society, the very basic point of Creative Society project. And that is the idea of Creative Society. That is the very basis we unite on. And if we put this very goal in every area that we have, agriculture, medicine, everything, industry, economy, if we focus on human life, then we can really reach our goal, that we can really unite. I believe that as you have said, we can merge our potential and we can find many ways how to survive. Because for every single person, it is not possible to overcome, but we all together, we cannot even imagine what we can all together create. So thank you very much.
Everybody can help. And I don't care how downtrodden you are or how little you can do. Exactly 20 years ago, I was brought within an inch of my life. I was run over by a train and drug 100 yards underneath this thing. As the wheels were stopping, sparks were just flying all around, and I thought it was the end of my existence. And when the train stopped and I was laying there, emergency workers came to get me out, and they were just surprised to see I was alive and said, "Hey, we're going to get you out of there." And they finally got me out, and when I woke up in the hospital, completely broken, no longer able to use my legs, missing most of one of my hands, it doesn't work very well. So I'm literally, for all intents and purposes, I've been doing everything I'm doing now I've been doing with a single hand. I've got gigantic orchards going. I've got orchards and food production like you wouldn't believe. I've been making greenhouses. I've been building sustainable means of food, water, and shelter for a myriad of people. And yeah, I've had a lot of help. People have been volunteering to help me, but it started with this. That's all I had. All I had left was my hand and my mind. And if you've still got a mind and at least one hand, I bet you can make a big difference. And you know what? I bet you can do it with just a mind. I know several quadriplegics that are some of the most brilliant people I've ever met in my life. Because you think it's the fact of the matter. I've had a lot of time to sit around and read and think. But some people have literally been put in a place where all they can do is think. And they can help us out of this situation as well. That if you think about it, no matter how sick you are, no matter how tired you are, no matter how poor you are, you can always raise that level of your own abundance around you. You can always contribute to the people and the people in places, the people in spaces around you. You can always do something to help. You can always, pick up a can of paint and paint a wall if somebody needs it. You can always find tasks to help beautify the world around you. You can put a seed in the ground and you can tend it and you can watch it ultimately fruit. But not only that, you can do so much more. Let me tell you about what I did in my orchard. I have 26 different varieties of ancient trees. The oldest I've got is an apple tree, the Duchess of Oldenburg. And one of the beauty things about fruit trees is that you can take cuttings, you can root them, and you can go somewhere else. And it's almost like copy, paste, copy, paste. You can literally spread forests. You can literally, the power that you have when you really access the sheer force of nature that is always at everybody's fingertips. We are the most powerful species that has ever been as far as agriculture goes. We have the ability to transpose and make green the deserts. And that's actually the one book I have here out just really to show desert or paradise. And that's really the question. Do we want to see a beautiful oasis that we can all live together in? Or do we want to see everything turn to dust? Because we get to choose. It's at our fingertips. We have the power. I've studied a myriad of things, and I have to say it's fun. I love learning, and I love sharing, and I'm really looking forward to seeing what comes of everything and what comes next. I'll be really looking forward to building your greenhouse with you. That is something that I'll start. How big do you want it? 1,000, 2,000, 3,000 square foot? I bet that's you could use a 3,000 square foot greenhouse. Thank you all so very much for having me. Once again, from the bottom of my heart, the Creative Society and everybody involved, thank you so much for helping spread this message. Because the fact of the matter is, we are all in this together, whether people realize it or not. And what you're doing, I believe, is part of that ascending part of the cycle. You're being a force of unification, and that is absolutely what we need now, more than anything. So thank you for doing what you do, and I'm so glad you found me, and I look forward to participating in and brainstorming and getting to know all of you better in the future. I really do. And just all my love. May you and yours be blessed with peace, happiness, and safety from this day forevermore.
Really very inspiring sharing. Thank you for what you do, that you're open, that you want to share your knowledge with actually all the humanity. We are very honored to have to go through this opportunity, to go through this experience, the wonderful interview with you. It was very enriching. And I would like to also tell everybody, all our friends, our viewers, that the project Creative Society is open to everyone. It is the project of the whole humanity. And you're very welcome to join us on the website creativesociety.com. And as our futures, you have said, Joe, the ascending part is all our responsibility. Let's join together. Let's do it together. Thank you very much.
We hear reassuring speeches that if we do away with fossil fuels, the temperature increase can be kept within 1.5 degrees for the next 100 years. Unfortunately, we don't have that time. The truth is that humanity doesn't even have 10 years to spare. And right now, we can't influence the true causes of climate change. After all, the reason for that lie in 12,000-year cycle of catastrophes caused by galactic interactions. Do you have an idea how serious this is? The cycle of terrible cataclysms, which the Earth now has to go through, occurs on the planet every 12,000 years, and it has been described by various researchers in many scientific works and books. The Earth's core creates a magnetic field. The Earth's magnetic poles are movable. Their sudden shift is called geomagnetic excursion. And note in which time intervals such excursions took place over the last 120,000 years. The interval between them is approximately 12 to 13,000 years. It is shocking that at the same time, there were sharp rises in world sea level, glaciation, and the strongest volcanic eruptions. Each time during such excursions, the magnetic field of the Earth became 8 to 10 times weaker, and this led to an increase in the flux of cosmic radiation. Modern science cannot explain why geomagnetic excursions coincide with dramatic climate change and glaciations. At the end of 20th century, Hartmut Heinrich did a great study. He collected data on the bottom sediment of seas, lakes, and rivers. And using them, he reconstructed all the dramatic temperature changes over the past 100,000 years. These changes were called Heinrich events. Each such cycle corresponds to a short period of glaciation, preceded by a sharp warming of the planet by 8 to 10 degrees Celsius. Dating the Heinrich events, Sidney Hemming in 2004 published her version of the periodicity of the abrupt temperature changes, where the events of the 12,000-year cycle clearly stand out. Geologists have also studied organic material from sediments over the past 75,000 years, which indicate the periodicity of the melting of massive glaciers. Douglas Vogt, geologist, has analyzed the carbon-14 dating of sediments and listed the works supporting this glaciation in his book. The data obtained irrefutably prove that glacial periods have cyclicity of about 12,000 years. It is known that over the past 100,000 years, as a result of melting glaciers, the level of the world's ocean has changed dramatically by 20 to 50 meters many times. This was reflected in the sediment of marine flooding. And also geologists recorded that over the past 2 million years, simultaneously with the glacial periods and polar inversions, there was an increase in volcanic activity. Another proof of the 12,000-year cycle was the eruption of the Toba volcano 72 to 74,000 years ago. It was one of the strongest eruptions on Earth in the past 25 million years. Archaeologists believe that across the whole planet, only 2 to 10,000 people survived in this catastrophe, and that humanity passed through a so-called bottleneck. In other words, it was one step away from extinction. The most destructive volcanic eruption in history, which occurred in other 12 millennial cycles, were the eruption of Phlegraean Fields, Taupo volcano in New Zealand, Lake volcano in Europe, Mount Vesuvius, Santorini, Ira, and many others. Such is the cycle of 12,000-year cataclysm in its apogee. And this time, it will be stronger than usual because it falls on a difficult period of time when a very sick planet, which we ecologically tormented, is added to a 24,000-year cycle. We have already faced a ruthless enemy that is destroying us. We have no time to continue staying idle, as the synchronization and cascade of the ongoing cataclysms is growing inexorably. We need to find a solution on how to put up a defense against our only external enemy. The enemy is strong, therefore all the power of uniting 8 billion people is needed. We need to use all our scientific potential, but this is impossible in the format of consumer society we have now. Today, science serves private capital, not the salvation of humankind. That is why we so urgently need the format of creative society, where it is not the private interest that will dominate, but our common human interest that will. We must hurry to unite and mobilize all scientists. All scientific, technical, and intellectual potential needs to be invested in one task: finding solutions to counter the impact of cyclicality, since every action has its counteraction. We will be able to find a solution to avoiding climate collapse and to humankind survival only when all of humanity consolidates. The choice is up to us. It's up to each one of us. It's up to you.